Hey there, space enthusiasts. Did you know that Earth is about to get a brand new moon? Yes, you heard that right. Our planet might soon be capturing a new companion in its orbit. But how is this even possible? And what does it mean for us? Stay tuned as we dive deep into the fascinating process of Earth potentially acquiring a new moon, the science behind it, and what it could mean for our understanding of the cosmos. Don't forget to like and subscribe for more mind-blowing space content. Before we get into the specifics of Earth's new moon, let's talk about what a temporary satellite is. Unlike our permanent moon, a temporary satellite, or a mini-moon, is an object that is temporarily captured by a planet's gravitational pull. These objects can be asteroids or space debris that find themselves in just the right spot to be caught in Earth's gravity, orbiting for a while before being flung back into space. Think of them as cosmic hitchhikers that stay for a bit and then move on. Although these mini-moons are usually small and don't stick around for long, they offer us a unique opportunity to study the dynamics of our planet's gravitational influence and the behavior of nearby space objects. So, what's the scoop on this new mini-moon? Astronomers have been tracking an object currently known as 2023 SO, which is on a trajectory that might bring it close enough to be captured by Earth's gravity. While it's too early to say for sure, preliminary data suggests that this object could become a temporary satellite of our planet. Unlike previous mini-moons that were relatively small, this one is a bit larger, making it a particularly interesting subject of study. It could orbit Earth for several months, or even a few years, before eventually drifting away, possibly influenced by the gravitational pulls of the Sun or the Moon. Understanding this object's behavior will help scientists refine their models of how these captures occur and their potential effects on Earth. Capturing a mini-moon is no small feat. For Earth to catch a new companion, the object has to enter a very specific part of space known as the Hill sphere, where Earth's gravitational force is dominant over that of the Sun. But that's not all velocity and angle matter too. The object needs to slow down just enough as it passes through this region, so it doesn't zoom past us. Instead, it falls into a stable orbit around Earth. If it's moving too fast, it will escape back into space, but if everything lines up just right, Earth temporarily gains a new moon. This delicate balance is why mini-moons are rare, and why astronomers are so excited whenever one is detected. So why should we care about a new mini-moon? For scientists, this is a golden opportunity to study an object in detail that we wouldn't normally have access to. It's like a free sample of an asteroid delivered right to our neighborhood. Scientists can learn a lot about the object's composition, its trajectory, and how such captures can influence both the object and Earth. It could also help us understand more about the early solar system, when many more objects were likely captured by planets. Plus, studying these objects can offer clues on how to protect Earth from potential asteroid impacts in the future. Capturing a new moon isn't just a cool cosmic event. It has practical implications for future space exploration. Imagine if we could predict and capture these mini-moons on purpose. They could serve as stepping stones for missions deeper into the solar system, or even as practice targets for asteroid mining. This could pave the way for new technologies and strategies in our quest to explore and utilize space. Moreover, understanding these objects better can help us prepare for any future scenarios where a mini-moon could pose a risk to Earth. It's a small piece of the cosmic puzzle, but every discovery brings us one step closer to mastering the final frontier. Did you know that this isn't the first time Earth has captured a mini-moon? In fact, we've had a few temporary visitors before. One of the most famous mini-moons was 2006 Roan 120, which orbited Earth for about a year from 2006 to 2007. Another one, called 2020 Seed 3, was detected in 2020 and remained in Earth's orbit for a few months before breaking free. These events have been rare and fleeting, but each one has provided valuable data that helps scientists understand these phenomena better. The study of mini-moons is still relatively new, but with each discovery, we get a clearer picture of how our planet interacts with its cosmic surroundings. Spotting a mini-moon isn't easy. These objects are often small, dim, and move quickly against the backdrop of space. So how do scientists manage to find them? The answer lies in a combination of technology and vigilance. Powerful telescopes around the world, like the Pan-ST ARRS Observatory in Hawaii, scan the skies night after night, looking for any sign of movement. Advanced software then analyzes the data, comparing it to known objects. If something unexpected shows up and has the right trajectory, it might be a mini-moon. But even then, astronomers need to watch it for a while to confirm it's actually in orbit around Earth and not just passing by. Interestingly, the thousands of artificial satellites orbiting Earth can sometimes help in detecting mini-moons. These satellites are equipped with sensors that constantly monitor their surroundings for potential collisions. Occasionally, these sensors pick up on unexpected objects, which can lead scientists to investigate further. If the object has the right speed and trajectory, it could be classified as a mini-moon. This shows how even the technology designed for everyday purposes can contribute to scientific discovery. However, it also means that mini-moons can pose a risk to these satellites, making it even more important to track them accurately. It's easy to confuse mini-moons with space debris, but they're quite different. Space debris refers to defunct satellites, rocket parts, and other man-made objects orbiting Earth. Mini-moons, on the other hand, are natural celestial objects like asteroids that are temporarily captured by Earth's gravity. While space debris poses a significant risk to satellites and space missions, mini-moons are more of a scientific curiosity. Understanding the distinction is crucial because the strategies for dealing with them are very different. Mini-moons provide a unique opportunity to study natural space objects up close, while space debris presents a growing challenge for space safety. Our permanent moon plays a significant role in how mini-moons behave. As a large gravitational body, the moon can alter the path of any object that comes too close. This gravitational influence can either stabilize a mini-moon's orbit around Earth or, conversely, eject it back into space. Understanding this dynamic is crucial for predicting how long a mini-moon will stay with us. It's a complex gravitational dance where the mini-moon, Earth, and the moon are all pulling on each other. This interplay of forces is what makes predicting the orbits of these temporary visitors so challenging and fascinating. One of the first questions people ask when they hear about a new mini-moon, "Id hit us?" The good news is that most mini-moons are too small to pose any real danger. They're typically only a few meters in diameter and would likely burn up in Earth's atmosphere if they got too close. However, studying mini-moons can help us better understand how larger objects might behave if they were on a collision course with Earth. By learning more about these smaller objects, scientists can refine their models and improve our planetary defense strategies against potentially hazardous asteroids. The idea of visiting a mini-moon might sound like science fiction, but it's not entirely out of the question. If a mini-moon stays in Earth's orbit long enough, it could become a target for a space mission. Such a mission would be an incredible opportunity to study a celestial object up close without having to travel far from Earth. It could serve as a test run for asteroid mining or even for missions to larger, more distant asteroids. While we're not there yet, the possibility of a human visit to a mini-moon could be a game changer for space exploration. Speaking of asteroid mining, could mini-moons be the first step in harnessing the resources of space? These objects, while small, could contain valuable materials like metals and water ice. If we could develop the technology to capture and mine them safely, mini-moons could provide a near-Earth source of resources for future space missions. This could reduce the need to launch materials from Earth, lowering costs and making space exploration more sustainable. It's a big if for now, but the potential is there, and each new mini-moon discovery brings us a little closer to that possibility. Just as it's tricky for Earth to capture a mini-moon, it's equally challenging for one to leave. A mini-moon can be ejected from Earth's orbit if it gets too close to the moon, or if its orbit decays over time due to atmospheric drag. If it's low enough, additionally, gravitational interactions with other celestial bodies, like the Sun or even other planets, can change its trajectory, sending it back into space. These unpredictable factors make it hard to say exactly how long a mini-moon will stay, but studying these processes helps us better understand the dynamics of our solar system. Believe it or not, you don't have to be a professional astronomer to help track mini-moons. Citizen scientists play a crucial role in monitoring these objects. Amateur astronomers around the world use their telescopes to observe the night sky and report their findings to organizations like the International Astronomical Union. These observations can be vital for confirming the presence and orbit of a mini-moon. It's a fantastic example of how anyone with a passion for space can contribute to scientific discovery. So, if you've got a telescope and a love for the stars, you could be part of the next mini-moon discovery. Each mini-moon that Earth captures is like a time capsule from the early solar system. These objects have been floating through space for billions of years, untouched and unchanged. By studying them, we can learn more about the conditions that existed when the planets were forming. It's like getting a glimpse into the past without having to leave our cosmic backyard. These tiny visitors can provide clues about the composition of asteroids and the dynamics of the early solar system, helping us piece together the history of our celestial neighborhood. Earth isn't the only planet that can capture mini-moons. In fact, astronomers are actively looking for temporary satellites around other planets in our solar system. Jupiter and Saturn, with their massive gravitational fields, are prime candidates for hosting mini-moons. Finding these objects around other planets could help us understand how common this phenomenon is, and whether it has any implications for planetary formation and evolution. It's a challenging task, given the vast distances and the small size of these objects, but the potential rewards are huge. Believe it or not, mini-moons could play a role in humanity's journey to Mars. These small objects could serve as waypoints or refueling stations for missions traveling between Earth and Mars. By using the resources from mini-moons, like water ice, we could reduce the amount of material that needs to be launched from Earth, making the mission more cost-effective and sustainable. While this idea is still in the theoretical stage, it's another example of how these tiny objects could have a big impact on the future of space exploration. Where do mini-moons come from? Most of them are likely small asteroids or fragments from larger ones that have been nudged onto a path that brings them close to Earth. However, some scientists believe that a few mini-moons could be fragments of our own moon, knocked off by ancient impacts and sent into space. Understanding the origins of these objects could give us new insights into the history of our solar system, and even help us identify potential hazards before they get too close to Earth. It's a mystery that scientists are eager to solve. As technology advances, our ability to detect and study mini-moons will only improve. New telescopes and space missions dedicated to surveying the sky could help us find more of these temporary companions. There's even talk of launching small spacecraft to intercept and study mini-moons up close, giving us unprecedented data on these elusive objects. With each new discovery, we'll learn more about the dynamics of our solar system and the forces that shape it. It's an exciting time for space science, and mini-moons are poised to play a big role in our exploration of the cosmos. Artificial intelligence, AI, is becoming an invaluable tool in the search for mini-moons. With millions of objects moving through space, it's impossible for humans alone to track them all. AI can analyze vast amounts of data from telescopes, identifying patterns and anomalies that might indicate a mini-moon. Machine learning algorithms can be trained to recognize the subtle differences between a potential mini-moon and other types of celestial objects, like space debris or distant stars. This technology allows us to identify and study these temporary satellites more efficiently than ever before, opening up new possibilities for discovery. Mini-moons could serve as inspiration for a new generation of space missions. Imagine a fleet of small, agile spacecraft designed to explore and sample these objects up close. Such missions would not only provide valuable scientific data, but also pave the way for more ambitious projects, like asteroid mining or even planetary defense strategies. By testing technologies and techniques on mini-moons, we could gain the experience needed to tackle larger and more distant asteroids. This incremental approach could be key to our long-term plans for exploring and utilizing the resources of the solar system. Why are people so fascinated by mini-moons? Part of it is the novelty after all. The idea of Earth having more than one moon, even temporarily, is pretty cool. But it's also a reminder of the dynamic and ever-changing nature of our solar system. Mini-moons challenge our perception of what we thought we knew about our planet's immediate surroundings. They serve as a reminder that space is not a static place, but a constantly shifting and evolving frontier. This public interest can be a powerful driver for funding and support for scientific research, helping to fuel further discoveries. You might wonder, what do mini-moons have to do with the search for life beyond Earth? While they're unlikely to host life themselves, mini-moons could help us understand the distribution of water and organic materials in the solar system. If we find that some mini-moons contain water ice or carbon-rich compounds, it could suggest that these building blocks of life are more common in our cosmic neighborhood than previously thought. This, in turn, could bolster the argument that life might exist elsewhere in the solar system, perhaps on moons like Europa or Enceladus. Beyond scientific curiosity, there's also an economic angle to consider. Mini-moons, if they contain valuable resources, could be a boon for the burgeoning space economy. Companies are already eyeing asteroids as potential sources of rare metals and water, and mini-moons could serve as convenient, accessible targets for early mining ventures. If we can develop the technology to safely capture and utilize these objects, it could kickstart a new era of space-based industry, reducing the need to launch resources from Earth and potentially lowering the cost of space exploration. Studying mini-moons isn't easy. These objects are often small, dark, and move quickly, making them difficult to detect and track. Even once they're identified, gathering detailed data can be a challenge due to their size and distance from Earth. Traditional telescopes may not have the resolution needed to study their composition or surface features. Moreover, because they're temporary, time is of the essence. Scientists only have a limited window to study them before they drift away. These challenges make each mini-moon discovery a race against time, requiring quick, coordinated efforts from astronomers around the world. The study of mini-moons offers a unique opportunity for international collaboration. No single country has the resources to track and study all potential mini-moons, so astronomers and space agencies around the world often work together. By sharing data and resources, they can confirm the presence of mini-moons, refine their orbits, and conduct more detailed studies. This collaborative spirit not only advances our understanding of these objects, but also strengthens the global space community. It's a great example of how science can bring people together, even as we look outwards towards the stars. While most mini-moons are temporary, some might stick around for longer periods. These objects could be in stable orbits that last for decades or even centuries before eventually breaking free. Studying these long-term mini-moons could provide insights into the stability of orbits around Earth and the gravitational influences that keep them in place. If we can identify and track these long-term visitors, they could serve as natural laboratories for studying the interactions between Earth, the Moon, and other celestial bodies over extended periods of time. The existence of mini-moons raises an interesting question. What exactly qualifies as a moon? Traditionally, we think of a moon as a large, natural satellite that orbits a planet over long periods of time. But mini-moons don't fit neatly into this definition. They're small, temporary, and often irregular in shape. This has led some scientists to suggest that we need a new term to describe these objects, one that reflects their unique characteristics. Whether we stick with mini-moon or come up with something new, these objects challenge our understanding of what it means to be a moon. Ground-based telescopes are essential for tracking mini-moons, but space telescopes could play an even bigger role in the future. Positioned above Earth's atmosphere, space telescopes like the Hubble Space Telescope or the upcoming James Webb Space Telescope have a clearer, unobstructed view of the cosmos. They could be used to study the composition, size, and trajectory of mini-moons in more detail than ever before. As new space telescopes are launched, they'll provide even more powerful tools for discovering and understanding these temporary visitors. Mini-moons, while small, can help us prepare for larger threats. By studying how these objects interact with Earth's gravity and atmosphere, scientists can refine models of how larger asteroids would behave in similar situations. This information is crucial for developing strategies to protect Earth from potential impacts. If we can predict the path of a mini-moon with high accuracy, we can apply the same techniques to more hazardous objects, improving our planetary defense capabilities. It's a small step, but an important one in keeping our planet safe from cosmic threats. A new mini-moon could also have a cultural impact. Throughout history, humanity has looked to the skies for inspiration, and the appearance of a new celestial object could capture the public imagination in profound ways. Artists, writers, and musicians might draw inspiration from the idea of a new moon, and it could even become a symbol of exploration and discovery. Just as the Apollo missions inspired a generation, the discovery of a new mini-moon could spark new interest in space and our place in the universe. Space agencies like NASA and ESA, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.